What's the opposite of 3 over 4? Okay, 4/3 is the reciprocal. What's the opposite? Negative 3/4. Okay, so the opposite is just simply negative 3/4. Okay. All right. So now remember before when we talked about symmetry, right? We talked about x-axis symmetry, we talked about y-axis symmetry, and we talked about origin symmetry. Good. Okay. So now, two of those types are when we're dealing with functions. Okay, we've talked about functions now. So which one are we probably not going to talk much more about now if we're dealing with functions? Yeah. X-axis symmetry, right? Because if there's x-axis symmetry, that means it's not a function, correct? Okay? So we're not going to talk about x-axis symmetry much anymore, but we are going to talk about y-axis symmetry and about origin symmetry today. Okay? All right. So let's review a little bit some of the stuff we've done. So if I have y-axis symmetry, so if xy is on the graph, what else is on the graph? Yeah, negative x and y, correct? Okay, so this means that f of negative x is the exact, is f of negative x opposite, or is it the same? Okay, so all right, let's look at a function. Let's look at right here. Okay, so if I have x, let's say x is 2, right, what's y? Or what's f of x going to be? It's going to be 4, right? So if x is 2, f of x is 4. Now what if I did f of negative 2? What's that going to be? 4. Oh, okay. So then f of negative x is the exact same as f of x. In other words, f of negative x equals f of x. Okay. Now, is everybody clear on that? Does that make sense? Okay. All right. So now we call this type of function an even function. So if f of negative x equals f of x, then it's an even function. Okay. All right, now, symmetry with the origin. All right, remember that? So if xy is on the graph, then so is negative x, negative y. Good. This means that f of negative x is the exact, now it's the exact opposite of f of x. In other words, f of negative x equals negative f of x. Okay. So again, remember y cubed, okay? We won't plot exact points, but remember that looks something like this. Okay. Now, if y-axis symmetry is even, guess what origin symmetry is? What kind of function is it? It is called an odd function, correct? Not odd as in weird, but odd as in not even. Okay, maybe that is weird. Okay, so now again, the other type of symmetry is x-axis symmetry. We don't deal with it because we are not looking at functions. Okay. All right, so let's talk about how testing to determine if a function is even or odd. Okay. So if a function is even, we simply replace x with negative x. Okay, and then simplify. If you get the exact same as the original, then you have an even function. So then with an odd function, if you get the exact opposite, then it's an odd function. Okay, and again, we're always replacing x with negative x and simplifying. Okay. All right, so now, again, looking at a graph, we've done these before. It's pretty easy to determine whether it's even or odd or neither. Okay, so far left, even or odd or neither. That is even. Middle, neither. Far right? Yeah, because that has origin symmetry. All right? Easy stuff. Okay, so now, looking at an equation, whether it's easy or odd, can be easy sometimes, but sometimes it's a little tricky. So you really do need to replace x with negative x and go. Okay? So let's look at some of these and figure it out. All right, part A here. So if I replace x with negative x, what am I going to get? I'm going to get the exact same thing, right? Because I have all even powers, so all those negatives are going to cancel out. So if I get the exact same equation when I plug in negative x for x, what kind of function do I have? It's an even function. Okay? And in fact, you'll find that that's the case. If all of the exponents, all the powers are even, the function is even. That's why we call it an even function. There we go. Not a whole lot of creativity in mathematics, people. I'm not going to lie here. Okay, so let's look at part B. So 2x cubed plus x. Now, all the powers are odd. I wonder. Right? Let's plug it in. So we end up with 2 times negative x cubed, which is negative 2x cubed minus x. Is that completely opposite? Everybody say yes.
Yeah.
Yes. So that is an odd function. So if all the powers are odd, it's an odd function. Okay. Let's look at part C. X, bless you, x cubed minus 1. Okay, so if I plug in negative x, right, I get negative x cubed minus 1. Is that completely opposite? It's not, is it? So this is neither or neither. Okay. Now remember, a constant, okay, that's like x to the 0 power. Okay. And in this case, zeros, we're going to consider 0 even. Right? So all our powers are not odd there. Okay. All right. Y equals the square root of x. Okay. All right. So the square root of x now, let's look at that. So the square root of x is, if x is 0, y is 0. If x is 1, y is 1. If x is 2, well, y is the square root of 2. If x is 4, y is 2. So it's going to look something like this. Okay. So now, graphically, is that even, odd, or neither? That is neither. Okay. Now let's look algebraically at it. Hopefully you got that stuff written down because it's now gone. Okay. So I'm going to replace x with negative x. So I get y equals the square root of negative x. Okay? Now, if that's going to be true, what does x have to be? X has to be negative, right? Because then I get the opposite of a negative, and that wipes out and gives me a positive. Okay? So that one, so is that the exact same or the exact opposite? It's not. It is neither. Okay, part E, y equals x squared plus 9 over 3x. Now, when we get into rational functions, the rules change on us a little bit, okay? So it's not quite as easy. So now it is important to plug in negative x for x. Okay, so let's do that. Oh, stop. So we get y equals, well, what's negative x squared? That's just x squared. Plus 9, and then 3 times negative x is negative 3x. Okay? Now what can I do with that negative sign? I can move it out front, correct? Which I'm going to do. Bang. So, that doesn't look very good, does it? I mean, none of it looks very good. My handwriting blows, I get it, but... Okay, so here we are. So, even, odd, neither. This one is odd, correct. So even though we have an even power in there, okay, that is an odd function. Okay, part D. Now just looking at it, what do you think? What's your first thought? Okay, I'm hearing even, I'm hearing odd. How do we check? Plug in negative x, right? Okay, so up top, if I plug in negative x there, after simplifying, what do I get? It's just x to the 5th, correct? Everybody okay with that? Cool. Okay, on the bottom, what do I get? We get negative x cubed plus 1. Okay, now here's the question. Can I move that negative sign out front? This time I cannot. Why? Because that's attached to it right there. So I would have to factor the negative out and then move it out front. And is that going to give me the exact opposite or the exact same? It's not. So what's my answer? Answer is neither or neither. Okay. All right, so we okay with that? So be careful, all right? If it's a basic type function like this, where it's not a rational expression, okay, then it's easy to tell whether it's even or odd. But when we start getting variables in the denominator, exponents in the denominator, okay, then we got to make sure we test it and see, because it's not, the rules don't hold that way. All right. So let's talk about increasing and decreasing functions now, okay? So a function is increasing if, for any choice of x1 and x2 in L1 with it, oh my gosh, I don't even know what that means. No, I'm kidding, okay? Okay, so basically what it means is this, all right? If I choose x1 here and I choose, like, so if I choose x1 here, let's go, and I choose x2 right here, all right, if x1 is less than x2, which it is, if the function is greater on x2 than it is on x1, then it's increasing. Okay, now, what all that crap means is the function goes up from left to right. There you go. See, we mathematicians tend to complicate things, so. Question?
What if it goes like that? Like the x1 and x2 that you choose, and then it like turns back and goes that way.
Okay, then we will talk about that in a minute. Well, then it's not a function at that point, right? So it's always, so when it goes to left to right, it'll never turn back on itself. But it could go up, it could go down, it could go straight. Okay, so now when you're talking increasing, decreasing, and constant intervals, you always go from left to right. Always, 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 always. Okay? So when we're talking about intervals of increasing, decreasing, we are always looking left to right. So decreasing means a function goes down from left to right. The constant function, it stays the same from left to right. So what kind of line is it if it's a constant function? All lines are straight. It's a horizontal line. Right? We get that? All lines are straight. If it's not straight, it's not a line. By definition, it's not a line. But it's a horizontal line. Okay? All right. So maximum. The blank function value on an interval. What do you think the maximum is? The highest or biggest. Right. And the minimum would be the lowest or smallest. And now, when talking about maxes and mins, that there are some other terms that you need to know. Okay. All right. So one is called a local max or min, which means that that's the highest or lowest function on a specific interval of the domain. Okay. So that specific interval. That's a local max. So when I say local max, so we mean something like this. So if my graph does, I don't know, something like this, let's say. All right, this point right here, that's a local maximum. This point right down here, that's a local minimum. Okay? Because it reaches a maximum point, it goes up, increases, and then it turns and decreases again. So that's the local max. Okay. Now a global min or max means the highest or lowest function on the entire domain or on the whole domain. Okay. Now over here, local is the same. You also hear it called a relative max or min. And then global, you might hear an absolute. And I will actually use relative and absolute more often, so we just throw out, well, no, that's not true. Actually, I use local and absolute, so get some of each. Okay, so a couple things about these definitions. Increasing, decreasing, and constant functions can only be used to describe a function on an interval. Okay. So when a question is asked what the max or min is, so we've got, okay, so if I wanted this point right here, what is that maximum? Okay, it is asking for the function's value or the y coordinate. Okay, now if a question asks where that max or min is, it's talking about the x coordinate. Okay, and we'll talk about that more. I'll say, give me the max, tell me the max and where it is. So you say the maximum is 7 at -2, or at x equals -2, or something like that. Okay, but we will get into more details with that here in a second. All right, so let's talk here. Okay, so now example 3 says use the graph to define some of the examples of the vocabulary above. Okay, so this point right here, that's a local min. This right here is a local max. Now this point right here can be considered a local min, but it's also the absolute minimum of this graph, because that's the lowest point this function ever goes. Okay, and then the absolute maximum is obviously here, it would be infinity. Okay? All right, so let's talk now. So what's the domain here? All real numbers. Okay, right? And MathXL usually wants that in interval notation. Okay, what's the range here? And is 0 included? Yes, it is. So it's from 0 to infinity. Okay. All right, where is the function increasing? And again, remember this must be an interval. So it's increasing from where to where? From -1 to 1, and from 3 to infinity. Good, that's where it's going up from left to right. Now notice when you're doing increasing and decreasing, the points are never included. Why is a specific point not included? Because it's not increasing at that point, right? Okay, this point at -1 here, that is a minimum. That's a local minimum, okay? So it's not increasing at that point. So we don't include it. All right, so on what intervals is it decreasing? From -infinity to -1. And from 1 to 3. Good. Where is it constant? It's not, right? It's either increasing or decreasing or changing on those points, okay? Nowhere. Is there a local maximum? Or are there local maximums? Yep. Where? So it's at 1, and what is the local max? It is 2. Good, at the point 1 and 2. All right, is there a global max? Yep, there's always a global max and global min. And where is it? Yeah, it's everywhere. It's everywhere. So the global max is infinity. All right, local mins. Are there any local minimums? Yep. Okay, where are they at? Or where is it at? Yeah, there's the one at -1. And what is our local min? It is 1. Now, oftentimes, okay, this would be considered a local min, but because it's our global min, we're going to put it in that category, or our absolute minimum, okay? So, yep, there is, and it occurs at 3, and my global min is 0. Record any of that shut off. Okay. Dang. All right, well, that didn't get recorded, so I'm gonna let it run for a second so you can at least see that.